Draw a fully labeled diagram to the of the apparatus that should be used to measure the standard electrode potential E0 of oxygen in half equation. I mean, basically asking for drawing this electrode. Okay, so remember drawings were important. So it's a gas electrode with ions. So how do you draw gas electrodes? That's so there's going to be a gas jar, which is going to have the oxygen gas, and everything else would be part of the solution. So you would have, because there is, I mean, he's talking about this one. So there's H+1. So the solution is going to have H+1. That's going to be 1 mole per dm cube. So H+1 aqueous. That's 1 mole per dm cube. And water is obviously there. You would need a platinum electrode. Okay, so your electrode will be made out of that's going to be made out of platinum. Okay, is this clear?
Yep, it's clear.
So for the cell drawn, use the data booklet to calculate the E0 cell and deduce. As a cell, so he's talking about the full. He's saying, how would you measure the E0? So all electrode potentials are measured with respect to a. So you have to make the whole complete electrochemical cell. So all electrode potentials are measured with respect to the standard hydrogen electrode. So you're going to draw that. This is H2 gas. There's going to be H+1 in the solution. There's going to be platinum electrode. And you're going to connect them together by a voltmeter. And there's going to be one more thing, which is our salt bridge. Okay, so there's going to be a salt bridge. Is this clear?
Yep, it's clear.
And you can measure the E0 cell, which is you would have to find this electrode in the data booklet. So where's that? The water, oxygen, and H+1, right? So the water, oxygen, so I think it's this one. I mean, their electrode is going in the backward direction. So it's 1.23 volts. This one is, so this is 1.23 volts. And that's your reference electrode, so that's always 0 volts. So the E0 cell is obviously 1.23, higher minus lower, and the positive electrode is going to be the left one. Okay, that's going to be our positive, and this is going to be our negative electrode. So we're gonna move